Hello, everyone, and welcome to another Jakarta Tech Talk. Joining us today is JJ Asghar, a developer advocate representing the IBM Cloud all over the world. He mainly focuses on the IBM Kubernetes service and OpenShift, trying to make companies and users have a successful onboarding to the cloud native ecosystem. He's also been known in the DevOps tooling ecosystem and generalized Linux communities. If he isn't building automation to his work streamlined, he's building the groundwork to do just that. If you have any questions for JJ as we move through today's presentation, feel free to ask in the chat or use the Ask a Question tab. Without any further delay, JJ, over to you.
Thanks so much. Yes, hello. Wow, already off to a great start. Voice cracking. Thank you for being here. If you wouldn't mind doing a +1 or a hi inside the chat to make sure I'm coming in just fine for y'all. And I'll flip over to my slides here. We'll see how we'll get going here. Perfect. Thank you, Dennis. Also, if you have questions while I actually do this, don't hesitate to throw them in the chat while I'm speaking. I like to have an interactive conversation. I've been told that I'm a whiteboard presenter where I come in, we start talking about it, and whatever the questions y'all have will help get the more out of the information that will be more valuable to you. My slides are just kind of like an outline, kind of keep the conversation going. But if you have questions, please don't hesitate to post them. And I will do my best to tie them into the conversation. So let's get going. And let's see here. We're going to go ahead and share that screen. Oh, and if anything embarrassing pops up while I'm sharing my screen, I apologize ahead of time. That was supposed to be a joke. All right, here we go. So hopefully y'all can see IBM. And then here we go. Again, hi, JJ, developer advocate for the IBM Cloud. And yes, I really do have the email address of awesome@ibm.com. And if you know anything about IBM, to be able to get an email address like that is quite impressive. And you can find me on Twitter and pretty much anywhere else online at JJ Asghar. I'm on GitHub and Twitter and LinkedIn and all that jazz. So never hesitate to reach out if I can ever help. So here to see migrating a monolith to cloud native and the stumbling blocks you might not know about, or that you don't know about. So your company has finally decided to move to the cloud native ecosystem. You've landed on containerization as your first step. You heard all you need to do was containerize your first app, push it to Kubernetes, OpenShift, Nomad, and this cost savings will just come. You've done this, and well, things just haven't gone as planned. Some of the tech didn't do what you expected. And wait, what do you mean our OpEx has gone up? Simply said, the promise of containerization or migrating to the cloud native ecosystem can be a lie if you don't do your homework. Sadly, most companies don't. And in this talk, I'm going to explain a few gotchas that a few enterprises in the guise of AsgharLabs hit moving towards the cloud native space. And hopefully you'll learn from their mistakes. So while you take your trip down this path, you'll be more comfortable and get closer to that promise that you've been told. So let's start out. What is AsgharLabs? AsgharLabs is a multinational tech conglomerate that bought hard into the VM ecosystem. They make ones and zeros like no other company, but notice they were falling behind. In all seriousness, AsgharLabs is a collection of different companies I've seen and worked with, and stories I've taken from them that I saw the same issues over and over again. And yes, it's a fake company, and no, they're not hiring. That was supposed to be a joke. So what did AsgharLabs think they had to do? They only thought they could take their migration from the physical data center or the co-location to the VM ecosystem, or just like the VM ecosystem. They used the same technique to move their monolithic applications to cloud native. If you ever played around in VMware or EC2, you know when you had that one bare metal machine back in the day that ran your application, you could just take that application, use some type of configuration management, and shove it up into EC2 instance or another cloud instance or whatever. Bare metal to the VMs is the same as VMs to containers, right? So where do I come into these conversations normally and to kind of help out with these different companies and different subsidiaries of AsgharLabs? I come into the conversation when they've had a few successful migrations. I beg to differ that they were successful, but they believe they were. They're nowhere near where they thought they could have been. They're nowhere near they thought they could be for the time and effort and the money they have spent. I come in as the cloud native person and ask some very simple yet tough questions. I have the privilege to spend my time in this ecosystem day in and day out, and I get to be that expert to so ask those questions to surprisingly hard, but really really important. So let's ask these questions right now. Let's ask those straightforward questions and discover that they're deceptively hard to answer. When I walk into a room and I talk to a company about these things, the first thing I ask when I actually get to the people who actually do the work, because companies usually have a few layers of people before you get to the people who actually do the work. You have to talk to the project managers, the executives, and all that jazz, and then finally you get to the engineers who are actually doing it. And I sit down in a room. Well, before this world we live in today, I used to sit down in a room with them, and I just looked at them and asked the very simple question of, who containerized your app? And you'd be amazed at how many people just don't really know. Was it your developers, your operations team? Were there more than a couple status meetings, AsgharLabs, between the project teams and who shipped it? Like, who sat down and actually turned this into the container that you use to push off to your application? Like, did you? Anyway, we'll get into more details in a minute. Second question. Well, why? why did you containerize this? AsgharLabs containerized their apps because they were told to. Not for some reason, not for any other reason. The execs needed to say that the core software was now their core software stack was now next gen. I actually saw this in another company moving to the cloud, and I was actually on the tail end of the problem of this before I became the cloud native person. I was actually helping companies move from bare metal to VMs. I got a lot to spend a lot of time and effort in the OpenStack and VMware space. And this one company I was working with, they were moving from their co-location data center and moving into something called OpenStack, which is VMs. And I remember coming in there to try to help them do that, and I was hired on to make this happen. And the interesting thing was, eventually I asked, why did we decide to go down this path? And it was because the CEO was on a way to a conference, and they pulled all that, that CIO magazine that you see in all business class places or business class airports or airlines. And they saw that the cloud was the next gen. And that she wanted their company to be next gen, to be able to tell their board that was going to happen. And the scary thing is that's happening again with containerization. People want to be the cutting edge. They want to move forward, and they want to be able to say that they are next gen, so they can bring in the next talent and all that jazz. And I ask why. That's not a good enough reason. There's more to it, and we'll get into those details in a second. Next question is, where did we deploy our application or our container? Or where are we planning on deploying our containerized app? This spurs from the conversation that is, are we using the cloud because of choice or because of an ELA? If you don't know, an ELA is an enterprise licensing agreement. Was it the best one for our company, or is it the one we were forced to use? How many times have I been to different companies out there where they were using some major cloud because it was attached to them buying some other software, and that was what we needed to do, but they were doing something different and using like machine learning or something. Well, when you think of machine learning, you think of a cloud immediately, specifically that cloud. Well, if they had an opportunity to choose the cloud they do, they would probably go down that path. But because of an ELA, they had to use that other cloud. And I understand as a representative of IBM Cloud, we have our strengths, we have our weaknesses. The other clouds out there, they have their strengths and their weaknesses. And you need to understand where you're going to put your application, because you need to figure out if that's the important one to do for your application and the advantages that are there. Not even talking about multi-cloud or hybrid cloud or all that jazz, because that's where people are moving towards. You can't put all your eggs in one basket. So you need to figure out where you're going to deploy this or where you're planning on deploying it to be successful. This is my favorite one. Um, what what do we containerize? Like, do we actually know? Is it just a container that somebody told us to run in our Kubernetes cluster or our OpenShift cluster? Like, what's actually in it? I don't know. How many times have I heard that? It's too many. This comes from the actual architecture of what you containerized. Now, I realize this is a Java group of people, so if I say this wrong, I'm sorry, but this is how I understand how this kind of works. I'm not a Java expert by any standard, but I can run run those applications really well. Let's just put it that way. AsgharLabs took a WAR file. Honestly, it could have been an EAR file, and threw it into the Java Docker container and called it a day. That was it. That's what they containerized. There was some Java app. They shoved it into a container, threw it up on Kubernetes, and called it a day. They're like, "We're containerized. We're next gen. All right, that's lunch. See you later." Like that's the kind of thing they would do. This opened up so many conversations with those people. I was just like, "No, no. There's do you know which Java container you're using? Do you know what the advantage, like what version of Java you're using? Like, there's so many things here that you need to think about." It also talked about the architectural changes that are coming from it, because we all know that the Java ecosystem, the WAR file is a monolithic app, right? Like you can run a WAR file and it's everything you need to run inside of it. That's actually not great for the cloud native ecosystem. And this talks about the architectural. I can't speak. I'm a professional speaker and I can't speak. Some architectural changes that actually have to come. So let's look at some of those right now. And because I'm an IBMer, I have to have WebSphere somewhere in my presentation. That was another joke. And this is the first one. This is exactly what that AsgharLabs subsidiary did. They replatformed. They took their WebSphere application or Java application, whatever you want to call it. It doesn't really matter. And they shoved it into a container and shoved it up on Kubernetes and OpenShift and said, "Hey, I'm done." Again, I know I'm repeating myself, but this is the replatforming, right? That's the first step. And a lot of people stop here, and that's wrong. Like that's just blatantly wrong. As soon as you take your first step down this path, you need to understand that there's more behind this. If your bosses say that's all you need to do, they really don't understand the advantages of cloud native. And the next one is repackaging to microservices. This is another good example of how instead of just taking that WAR file and shoving it in, they take their legacy application and their EAR file and break up into multiple WAR files and then put those migrated apps onto Kubernetes or OpenShift, and then have a shared message queue of some sort between them. Intercommunication inside of a Kubernetes cluster is actually done in a really interesting way. And it reuses these things called services so that everybody can find each other so they can talk and work together. So the advantages here is that you can actually have some message queue that your application sits there and talks to, and be able to do that pub sub that you look for. So as you start building out your application or re-platforming and re-architecting, you start thinking about repackaging it into microservices. Yes, I realize that it's just shoving another WAR file in there, but no longer is it just one big WAR file. Now it's a couple WAR files that do disparaging little jobs, and they have a shared platform with that message queue. Then finally, the final step, which is actually the longest step, is refactoring into something called the strangler pattern. The strangler pattern, if nobody knows, is the idea of basically slowly but surely turning your monolithic application into smaller and smaller microservices over time. Basically strangling down, if you will, if you imagine strangling down an application to smaller bits. So let's take a quick aside and talk about this for a second. You have this application. It does whatever. It doesn't really matter, right? It does something. Now, the beauty of the strangler pattern is you figure out some feature inside of your application. Let's take OCR, for instance, like scanning receipts, right? So you're a shop and you have to scan receipts for returns. Okay. You have your application, your monolithic app has that feature inside of that. Well, the strangler pattern, the idea is to be able to by its side spin up another microservice with um, with that same OCR ability. It doesn't matter what language it is in now, because the beauty of containerization is that it doesn't matter what language it's written in, which is great for performance. You start looking at the different languages and the advantages they have for that. And you write that new feature beside your application. You have it put into the Kubernetes cluster or the OpenShift cluster as another service inside of it that does the exact same thing that your monolithic app does. Then you find some way to run that in parallel and then put a little bit of traffic over to that OCR instance, that the little microservice. And then when you're comfortable that it's running the same path or even better than your monolithic application, you cut that portion out of your monolithic app. So now you have that smaller little application running that OCR. That also gives the advantage of now you can release new features or bug fixes to just that portion of the application now, instead of having to do a full cycle release of your monolithic app. So you do that over time, you strangle it down to much little different small little applications with the microservices. And then before you know it, you have all these different microservices running, and you be able to run and have their own their own history and their own ability to deploy, and you can work for it. Now, you can run this in Java. Absolutely. You can do Java across the board. It does not matter what language is run inside of the container. It's more of the architectural change. So you start focusing on, instead of big bang releases, you have small batch releases, right, of your different little bits of application. And before you know it, that velocity of your architecture will just skyrocket. Yes, up front, it'll take some time, but it'll skyrocket before you know. So I kind of already hinted towards this. So where are these architectural advantages and disadvantages? And I did already say this, but I'll say it again. The velocity will just completely change your ability. The ability to focus on their own histories and scoping to your clusters for what you actually need. Going back to that one company that just shoved their Java container, or sorry, their Java WAR file into a container and shoved it on a Kubernetes cluster. That was one of their biggest problems. This Fortune 50 company that is a subsidiary of AsgharLabs, let's just call it that, they brought me in because they actually saw it as a cloud native problem. They're like, JJ, we have this application and we have this 3-node Kubernetes cluster, which, by the way, 3-node Kubernetes cluster, you can pretty much run your business on an OpenShift cluster, a 3-node OpenShift cluster. It's good stuff. It really is. But they did it, and they shoved their WAR file in there, and they wanted to spin up more pods. So they wanted to be able to carry more load, because they had overnight, over US nighttime, their traffic would go down and it would pick up again during the morning. So they were like, oh, we need just more resources. So they brought me in and said, hey, JJ, why doesn't this like scale horizontally? Like, we have this 3-node cluster. Shouldn't we have 3 pods running with this thing to like work on it, do it? And I'm like, yeah, I mean, sure. Why not? Like, let's do it. They're like, well, we need actually like more machines. So let's look into the way to like spin up new ephemeral nodes, which are like the compute portions of it. And I was like, wow, you guys are really advanced. What's going on here? This is pretty crazy stuff. Like, yeah. Well, we've noticed that like during the day, only one pod just sits on this one node and not on the other 2. And I'm like, so you want to spin up more nodes? What's going on here? Well, the challenge here is they thought they were using containerization just like they use the VMs, where you would just have one VM that would sit on some hypervisor somewhere that would move around like in vSphere or whatever. They didn't understand that by breaking up their application, they can horizontally scale indefinitely to whatever the size of the cluster is. And that's really important to know, because now you can scope the cluster from what you actually need. Like, no longer do you need to spend hundreds of thousands of dollars a year on hardware that just does nothing. Now you can actually scope your cluster to be that X number of dollars cluster that can horizontally handle the amount of load that you expect to have because you've changed this into microservices. Again, this requires a huge, a higher level of cooperation. And you need to build out more integration tests, and you need to spend the time to really build into this world. It doesn't come by just shoving a container up into OpenShift. And frankly speaking, you're going to need a different deployment system. It's that simple. Like, you're going to have a different way to do it. No longer are you going to do what you do to deploy your application. Now, I didn't realize this at the time when I wrote this talk, but I used to work at a Dell Technologies subsidiary, and we had something called the CCB, which I thought was just a normal industry term, but we all have one of these things inside of our operations teams or development teams called the change control board. You might call it something else, I don't know, but the CC there is always that one room, or not room now, I guess, a Zoom call, where you have every single manager, middle management, that says go, no go, like, let's deploy the thing, or don't deploy the thing. You know that room. I'm telling you, you need to move away from this, because you're not going to be able to, inside the cloud native ecosystem, actually be able to use something like the CCB. No longer can you be gated by dev, QA, prod, random executive, random senior executive saying, yes, go deploy this thing. How many times did I see in that room at the Dell Technology subsidiary I was working at, where they would literally do the thumbs up, say go, no go. Now, if you're deploying possibly tens, if not 100 times a day, because you have all these different microservices, and you're in this advanced and mature, a better word is mature, infrastructure, that's all they're going to do all day, right? Like, they're not going to actually know what's going on. They're going to have to say yes, 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 yes. So the idea of that gating mechanism will disappear. You're going to have to start leveraging different technologies out there to be successful. So yes, your goal is to move away from the CCB and trust the bots to do the work for you. But we'll get into that in a minute. Hey, JJ, are we doubling up on things? Seriously. Why do I have this load balancer now if there's a load balancer inside of OpenShift? Or, why do I have the scheduler inside my application when I could just have the scheduler that's built inside of OpenShift? Yeah, you are. You're going to double up on stuff. It's that simple. You're going to audit. You're going to need to audit and verify you aren't doubling up on too many things. A great example was actually that Java Stack schedule conversation. That one company that I'm talking about, they actually had a scheduler built inside their Java application, and whenever they spun up a separate job to go do some ETL pipeline thing, it would spin it up inside of the pod, the second process, because that's how they were doing it. They were treating a pod as like a VM. And in their mind, they're like, oh, okay, so I spin up this pod, this new job, it'll kick over to one of the other nodes that are running the actual application. That's not how pods work. Pods stay on the same node. They can't cross nodes. They're one thing. So what they needed to do was spin up a new pod with that job inside of it. But they didn't know this, right? They didn't know that's how Kubernetes works. So imagine now you have all these different sub jobs being spun up. Now you can scope your cluster what you need. And then with you have two machines, two basically blank nodes, you can have as many of these jobs as you need. So no longer do you need to spin up a brand new cluster to do this. Now you have basically just adding another compute node if you need even more work. Otherwise, it's elastic. So, and then now, just picture that in your mind. Like, instead of spinning up a new cluster to run this big stack, now you just spin out nodes and use how many of you need. And Kubernetes is smart enough that if it's like, oh, I see a lot of work coming down the line, it can actually request from the different clouds out there a new node to spin up because it's like, oh, there's going to be a tidal wave of work coming. I need to I need to spin up another node of some compute, so it'll be ready. So now I can schedule a bunch of stuff over there. If hopefully that makes sense. If I can get a +1 to say that this makes sense, I would love to see that I haven't lost y'all. I realize it's a little bit scatterbrained. We'll see, maybe. On that same token, back to the load balancer idea. Um, there's a load balancer inside of Kubernetes clusters, right? Like that's the way it works, and that's how you load. And then there's these load balancers out there on the. Thank you, Ron or Renan. I appreciate that. Back to the load balancer idea is that when you have multiple pods behind it, you can have n number of pods. So you need a load balance between the work to do that. So there's our people who have bought load balancers from major networking companies out there, and they spent all this money on it, and they put it in front of Kubernetes, saying, "Oh yeah, we'll just let it do the load balancing for us." Well, now you have a load balancer in front of another load balancer in front of your pods. I'm not telling you to wire your Kubernetes cluster directly into the internet. God, no, I'm not saying that. But I'm just saying that you might not need that load balancer anymore. The load balancers inside of Kubernetes and OpenShift or the cloud native ecosystem rival those data center load balancers now. So all of a sudden, you can save money by not having to spend insane costs on hardware load balancers and just let the software do the work for you. Of course, you're going to have to work on your networking team, and et cetera, but that's still important to know. So yes, you will be doubling up on things, and you do need to audit these. You need to take those moments and really think about it. So, hey, isn't automation good here? And damn it, why are things so complicated now? Well, first of all, obviously automation isn't good here. With all these moving parts, you need to leverage automation and let the computers take on the human error prone part out of the equation. No longer are you going to have those people sitting around a room giving go, no go. You're going to have some Jenkins pipeline, Travis, it doesn't matter, GitHub Actions, it really doesn't matter, pipeline that runs those integration tests, those unit tests. And if everything turns green, the 4-eye rule is important. Make sure you have 4 eyes looking at a code change. You hit that merge, and then it kicks off and pushes it out to your new cluster. And congratulations, you've done a deployment. You do small batch deployments, no longer big bang. No longer do you wait till 3 o'clock in the morning on a Tuesday to release your application. No, now you can basically deploy when everything turns green. Again, that requires a lot more collaboration and whatnot, but it's important to know. And why everything's so complicated? Well, honestly, your app has probably always been this complicated. You just probably never seen it, right? You've never had to visualize the complexity that's required.
Hi, everyone. Looks like JJ just had a minute to reconnect. Sorry about that. When he's back on shortly, we'll get that going just in a second. Minor technical difficulties. Gotta love internet things. One moment.
Hi, sorry about that.
There we go.
Can you hear me? Hello? Okay, perfect. Um, sorry about that. It seems my VPN dropped. Can you tell me where I was in like what the last thing I said? Ah, perfect. Okay, so basically the short of it is you need to let the bots do the work for you, right? Um, and why is everything so complicated? It is, right? No longer are you going to have that one or two different our enterprise architects that understand how your application all comes together. Moving to microservices, you're going to start being able to share the load across the board. And I'll get into more details in that in a little bit. But a good friend of mine came up with this. When I was talking about this talk with him, he actually brought this up to me. He was like, JJ, you're basically telling your audience you had an ornery bull mastiff. Now you have 13 yipping chihuahuas. Now just take a moment and think about that. They're both dogs. If you didn't know, bull mastiff is a dog. Chihuahua, yo quiero Taco Bell, that little dog, right? You have 13 of them now you have to deal with. Or you have one really big dog to deal with. And that's your applications, microservices versus monolithic applications. 13 European Chihuahuas is still a lot of work to deal with. There's still a lot of things to work and coordinate with. But it's much easier to pick up a yipping Chihuahua and take them to the vet compared to trying to move a bull mastiff into a crate or whatever to take to the vet. So it's a really good way to visualize what you're trying to do. And on top of that too, who stole this quote from someone else. If something goes wrong, just as Ken says this right here, we replaced our monolith with microservices. So every outage now is like a murder mystery. Well, it's true, right? It really hits home because it becomes a murder mystery. Take a moment and think about that. No longer, unless you have aggregated log monitoring, which you probably don't, every log file will be unique to that service. You have to walk through each process, what it did when. You'll have to actually be like Sherlock Holmes and walk through the error that happened. More importantly, by moving to microservices, you will have to create some type of standardized logging standard. You'll be all have to agree that this is the way the logs need to come out. No longer is it just a Catalina.log on one random server. Now you're going to have a bunch of different containers having to ship their logs to something that a person who understands the application can dig through to figure out what's going on. Production outages happen, and you will have bugs and issues. And if you don't have this level of cooperation, you're just gonna it's gonna be painful, right? That's the short of it. By the way, Ken is an amazing guy to talk about CI with, continuous integration. He comes from GoCD. So if you want to see some really great concepts of leveraging automation to do shipping your code, Ken, look him up on the line. Basically, Ken, I can't pronounce his last name for the life of me. He's really good. So let's ask some questions you should ask about how this cultural shift will happen. And yes, I am talking about a cultural shift, right? Like you will see a cultural shift. I mentioned that CCB earlier. At AsgharLabs, the CCB became something almost like something out of the Phoenix Project. If you've never read the Phoenix Project, you absolutely should. It's a book about operations. It's basically Eliyahu Goldratt's The Goal, just with IT instead of building widgets or car stuff. I think was the goal. It's been a while. but it's using IT as the narrative and backdrop. And it's really well done. In the Phoenix project, nobody ever showed up to these CCBs or the equivalent of the CCBs. And it wasn't engaging, it was a burden, right? Like nobody wanted to go there and do the go, no go. Nobody wanted to go there to talk about this stuff, even though the whole idea was for cross communication. With moving to cloud native, you'll naturally have to start allowing for self orchestration of rollouts and updates. If your developers say, hey, we need to do this thing, right? And they got the patch and everything's green and the tests have added, so it tests how they expect it to, they should hit that merge button and ship it, right? Like that's the way the cloud native works. But there are companies out there that are going to be horrified of this. The idea that you put that power into developers or product managers or project managers or whoever they are, that's going to force some really strong cultural shifts. You'll lean more and more on that pipeline and collaboration to get the different widgets out there at the right time. So of course, you need to build that pipeline. With any cultural with the cultural shift to happen, you will need to build CI and CD, or continuous integration and continuous delivery. You'll need to leverage standards of linting and always to make sure there's a standard for your code. One of the main reasons why Golang or the Go language is so easy to read, believe it or not, is the Go format command, the GOFMT command. Go came along with a standard outside of the box. No longer is it like PEP8 or I'm blanking on the Java standards, or the JavaScript standards out there. Go came with a format, came with a format command and a standard outside the box. And it forces that no matter what. So at 3 a.m., when something goes horribly wrong with your application, your operations people are there, because they've been reading Go code all day, they don't have to use that cognitive overhead of why is that curly brace there, right? Because they read it just like a book. They visualize it because they've already been trained that they don't have to argue over tabs versus spaces or anything like that. Because they have a standard, they don't worry about the syntax placements. They just think about the logic. So leveraging CI and CD, you get the ability to have these types of linting and forcing these standards. Yes, your different developers are going to be up in arms about tabs versus spaces and stuff like that. But if you put this inside of your actual pipeline and agree that this is the way you need to write your code, some people are going to be annoyed, but eventually everyone will fall in line because it'll be red. The pipeline will be red. So, force it. The downstream ability is really, really great. You need to learn to collaborate with other teams. The hardest thing I saw at AsgharLabs was to deal with the actual collaborations between teams. They had some great propaganda around having a scrum and tribes. I still don't even know what that is and whatnot, but people still just wanted to do it the old way. And collaboration isn't just status meetings. It's more than that. It's declaring shared contracts for jobs and responsibilities with constant communication between teams. Jira tickets can only get you so far. One of the most successful things I ever saw an AsgharLabs subsidiary do, which took a lot of buy-off from executive management. Not going to lie, this is something you just can't implement because it's a massive change. With every sprint, they switched out one person from their tribe to another tribe for that global application. So imagine that. Every single 2 weeks, you have a brand new person inside your cohort where you need to train them. They need to understand what's going on, and they need to be able to commit some code before they're gone in 2 weeks. Initially, this put things to a grinding halt, right? Because now all of a sudden, you got to write all this documentation because you got a new homeboy here who knows nothing about what you've been doing for the last N number of years. But then all of a sudden, the next one has started going faster because you rewrote that documentation. You now train that new person. And now that new person that just came in, turns out they were an expert on that API that you've been having trouble with over on that other portion of the app. wait a second, they actually know who wrote that thing and can talk to them. Before you know it, it's no longer tribal knowledge. It's now shared knowledge. And then the ability for brand new human to come into the team and be functional very quickly becomes almost not instantaneous, obviously, but so much faster than the 6, 8 months you had to use to wait to ramp them up. You spend that time up front to be able to create this system. And if you have to train someone new every single week or every 2 weeks, believe it, the ability to get them to be functional, it just changes. And it'll add for new blood and new ways of things to come in to those teams where successes are happening. That subsidiary saw their velocity just skyrocket. It slowed down, but then it just picked up and went. And then also that overhead, or that turnover that we're all seeing inside of all the different companies work for, starts not being that big of a deal, frankly speaking, because if you have all the documentation and the way that things are run, if one of your homeboys decided, or one of your developers decided to win the lottery and decide to move on to something else, go build that farm upstate or whatever, or start that cidery or start brewing beer all the time, I don't know, whatever. Now you can just hire someone new off the street who has relatively close skill set, give them the documentation, and congratulations, and they're now doing the job. I get that. It scares people. What about my job security? What about like the things that I'm really good at? But now you can go do other stuff, right? Like no longer do you need to worry about the thing you used to understand all the time. Now you can actually learn new skills. Now you can spend that time, that effort that you have to be successful, to do new things. It's unbelievably freeing is the word I'm looking for. Sorry. Okay. I rambled enough about that. Hopefully that hit home. So with every talk, you need to talk about visibility and monitoring because everybody needs it, right? AsgharLabs thought they could just buy one product and call it a day. One product. Sorry, Nagios isn't going to cut it anymore. And they learned this the hard way. Sometimes you have to build you'll have multiple monitoring applications and visibility only portions of the apps that your teams care about. As badly as AsgharLabs wanted a single pane of glass, it's unrealistic with how many moving parts there are. Your teams are going to need to focus on the things that they can care about and worry about. And then, of course, you're going to have to like bubble it up to be higher and higher in different scopes. But it's important to recognize that. This is a huge culture shift inside of AsgharLabs. Most companies that I've been talking to, even especially through these COVID years, they're still dealing with this because they wanted just to be able to go buy that one application that promised that they could do everything, App Dynamics, and it didn't give the visibility of the things that they needed for a team, but they thought they could just get it all through that pane of glass. I have friends at that company. Don't get me wrong. I say that with jest. I mean, they have some really good products, but it's important to know that you need to build the tools. You need to find the tools that your teams need to be successful. So something that people don't really talk about too much until it's way too late is that how do the economics of the cloud differ from your data center? I mean, moving to the cloud native ecosystem, everything's OpEx now. Everything can be paid with a credit card. Well, okay, most of it can be paid with a credit card. CFOs go back and forth about this constantly when you talk to them. Some love it because assuming your team can keep control of your spend, the predictability of the spend is consistent, which is exactly what CFOs want. They want to be able, they don't want guardrail to guardrail spend. They want to know that it's a constant line either going up or maybe coming down a little bit and then going back up because they understand it's going to cost money to do this stuff. But as long as it's consistent and not guardrail to guardrail, CFOs are happy. But on the flip side, CFOs can be really, really, really annoyed with this because you can't depreciate this hardware anymore. It's amazing how many accounting firms tell tech companies to depreciate their hardware for the gap process of money. And no longer is this massive capex of buying a data center, something they can help balance the books with. As engineers, as developers, we don't really think of it this way, but there are whole teams of people out there who have to make sure that all the stuff, the books zero out correctly. And depreciation is something they lean heavily on. And when everything turns to OpEx or COGS or cost of goods sold, that causes some friction. So it's important to have those conversations. And hopefully your management team has at least walked through these changes with the stakeholders so they can at least talk about, okay, moving to cloud native, now we have to think of it this way. No longer is it me buying a data center with a bunch of VMware clusters inside of it. Now I'm going to random cloud and I'm using the corporate credit card. How is that going to affect our bottom line? Possibly save. At the same time, I know clouds don't, cap spend, right? So you could actually spend more money if you're not careful. So keep that in mind. Hey, JJ, what do you mean all our support's on Stack Overflow? It's another thing people completely forget. Well, yeah, honestly, a few places, yeah, that's pretty much where you're going to find it. Because there's not, there's few experts out there in this world. And they post to Stack Overflow. Don't get me wrong, it's community. People are willing to be helpful. But there's very few places for companies to turn to get that type of stability that they want to run their business. There are a lot of companies, including IBM, that leverage open source and build on top of it. One of the best examples is we've talked about Kubernetes, and I keep talking about this thing called OpenShift. If you didn't know, OpenShift is the enterprise grade Kubernetes cluster supported by Red Hat. And when you buy an OpenShift cluster, you get all the power of the cloud native ecosystem and also the ability to leverage the best in breed systems for Kubernetes for your downstream developers and the support of Red Hat behind it. So it's something really important to look at, especially from the enterprise space, because you put your business on here, you are going to need to have your bosses will want someone to talk to if something goes wrong. OpenShift is a great answer. There's other ones out there too. Don't get me wrong, but do your research. So I'm coming to the end of it here. If you have any questions or thoughts, please don't hesitate to throw them in the chat. I'm going to kind of wrap this up, and maybe I'll answer some questions live here in just a second. So let's talk about some tangible things you can start with to help you become more successful. There are a ton of technology and software to help you get going. The best thing you can really do is take a moment and figure out, when you containerize your app, what did you really containerize? Or did you just wrap it in a pod and wash your hands of it? Have large conversations about why you did this. Was it because you didn't want to be left behind like AsgharLabs? Or was it because you couldn't leverage some software to get better value for your customers? Ideally, with masking all these corporations I've had exposure to as AsgharLabs, it helps highlight some of these consistent issues I've seen. The best thing you can do first is ask, do we really need to? If you're really committed, well then take a beat and look for those optimizations instead of features. I know bosses hate that, right? Like they hate slowing the ship, but sometimes you got to slow the ship to move fast, to understand, it's time for us to switch out that engine or whatever. This will drive your teams crazy. But the more you pay up front and use the correct tool for the job, the better you'll get, the better returns you'll get. Or to quote another great friend of mine, Thomas Cate, you wouldn't use a saw when you needed a hammer, or a hammer when you needed a saw, right? Just take a moment and think about that. He's telling you, use the correct tool for the job. Of course, you can use a saw to hammer in a nail. You're going to look like an idiot, but it'll work. Or you can use a hammer to break a piece of wood, right? It's going to take some time, but it'd be much easier to use a saw. So take a moment and think about that. As you move down this path to cloud native, use the right tool for the right job and do your homework. Thank you so much. Again, awesome at IBM.com and at JJ Asghar. I'm always willing to help. never hesitate to reach out. If I can answer any questions, I'd love to answer them.
Amazing. Thank you so much, JJ, for that excellent presentation today. Just a reminder, if anyone in the audience has any final questions, please feel free to ask them in the chat or use the Ask a Question tab. And I'll give you a few moments while I wrap everything up. So the next Jakarta Tech Talk happens March 16th when Ottavio Santana and Karina Varela join us to present the 5 skills you must master to be outstanding as a software engineer. You can register for that session using the link that I'll be posting in the chat. We're also looking to book more Jakarta Tech Talks throughout 2022. So if you're interested in presenting, feel free to fill out the form, which I have also linked in the chat. And finally, if you have any feedback on the Tech Talk program, we'd love to hear from you. Just click the green button that popped up and let us know you enjoyed the talk. All right, so it doesn't look like there are any more questions. So again, I'd like to thank JJ for the fantastic presentation, and thank you everyone for attending. I hope you have a great rest of your day.